is still a bit up in the air. Will it be acquired? Will it be leased? Will there be an easement? What will happen? We don't know. But in theory, yes, the property behind the storage dam could still be farmed during terms when it's not inundated. You may have heard about the Miami Conservancy District, which is south, in and around Dayton. And they have many of these types of dams. They have 5 of these types of dams, and that is exactly what happens at those structures. In some of the areas that are inundated more frequently, they've kind of turned those into parks in some places. The places that are inundated less frequently, for example, here, that kind of southern part, they do lease it as farmland. So yes. I had some questions about how the Miami Conservancy District operates. Why not put the public to a vote on this? Will people have a vote? The way the Conservancy District is set up, the judges that represent the 15 different counties are elected, and they appoint the board. So the process of you influencing the Conservancy is through election of the judges. Removal of the riffle structures affect the river's water quality in low flow conditions. Will the river stagnate? So actually, when you remove these structures, the water quality of the river will actually be improved. What happens in these low dams, you have poor water quality behind them. You have higher water temperatures, you have lower dissolved oxygen. You typically have kind of a low pool, if you will. And the flowing water actually improves the water quality in these structures. Dam removal is done very commonly around this state. I've been involved in several low dam removals like this, and a lot of times they're done specifically to improve water quality. The river will not dry up. It will narrow a bit, so the width of the low flow channel, the low flow water width, if you will narrow a bit when these structures are taken out. There's also a question about the hydraulic improvements. Will it send more water downstream to Ottawa? We did look at that extensively. The hydraulic improvements do not have an adverse impact as you move away from the project. Question about how the rainfall was obtained. So we got a couple different paths here. For the planning level concepts that I presented tonight, you see that we used. Let's see if I have it here. And for the planning level concepts I've done tonight, we've used a conceptual 5 inches of rain distributed over the watershed. That was done for planning purposes. It's an industry standard that engineers use. When we go to more detailed design and when we start to develop these concepts further, if they do move forward, we'll do site-specific hydrologic studies. We'll look at historical rainfall data and develop general storms for the area. It's a question here about the Corps of Engineers impacting only 200 acres, whereas we're impacting more acreage. Actually, the Corps of Engineers report shows 960 acres of impact. The 200 acres is just the impact of just the narrow focus of the channel. But the overall impact of the whole project is actually much greater. It's 960 acres. So it's a lot closer to the Eagle Creek Basin. They're similar. What did Stantec learn from the levee failures in Missouri? Well, we're not proposing any levees here. The levee failures in Missouri are on the Mississippi River. They're much different structures than what we're looking at here. These are dams, not levees. They're much smaller in scale than the levees on the Missouri. It's not really an apples to apples comparison. Let's see. Question about cleaning the Blanchard. Has there ever been a study done to clean the Blanchard? And what would it cost? Well, we did look at it. This goes into the whole concept of continuing the hydraulic improvements up or downstream of where we have them right now. We looked at a number of different ideas. We looked at widening the whole channel. We looked at removing more dams, or removing more bridges and raising more bridges. We looked at doing things like clearing, snagging trees and that kind of stuff. When we looked at a bunch of different options, and the result was really a very minor drop in any water surface elevation for the 100-year event. We're talking tenths of a foot, so very, very minor drops. So as you start, what we've done is we focus our hydraulic improvements on an area where you get the biggest improvement. You get that 1 foot drop in the 100-year water surface elevation. As you move either upstream or downstream of that, the impact on the Blanchard River is muted. It's closer to where that's impacted. So the impacts to the number of structures and the businesses and the roads that are more dense in town, as you move away from town, those impacts are muted as you go down. So we didn't look at the cost because the benefit of the hydraulic benefit just isn't there. Talked about overall benefit cost ratio work, considered how was that done? Was it just Findlay? A lot of questions about, was it Findlay? Was it different communities? Was it the town of Mount Blanchard? Was it different areas? We looked at this from a regional perspective. When I say regional, I mean countywide perspective. So the benefits we looked at, the impacts we looked at, the property that would be acquired, the impacts for the construction, as well as the benefits, were looked at on a regional scale. So it's taken as a whole county, the Hancock County as a whole. There's a question about the benefit cost ratio. What would the benefit cost ratio be if just the basins were done? Or what would the benefit cost ratio be of just one dry basin? We haven't done that, and the reason is we looked at this thing as a program. Frankly, the detention basin, the dry storage basins at Eagle Creek and at Mount Blanchard and at Potato would be a lot different. We would design them a lot differently. We would come up with a different conceptual design if they were to be done on their own. So we haven't really looked at the benefit cost ratio of one of those individually, because we would have to do a new concept design around that piece of infrastructure to do the benefit cost ratio, because it would be designed differently. So the Mount Blanchard area, why not call the 3 earthen structures all dams? Well, they are all dams. It's a different type of dam. Let's see if I can show it here. So there are a couple dams on here that are what we call saddle dams. So this dam right here is a saddle dam. So it's not part of the main dam across the tail. It's a saddle dam that prevents floodwater from spilling over. So in engineering terms, those 2 structures are considered linked.
What does the state of Ohio consider these dams?
Same.
No, what restaurant?
I'm going to get to that question. It's in here. Is the Main Street Bridge at Pinch Point? Well, we looked at all the bridges. We looked at the Main Street Bridge and all the bridges up into Blanchard. The real pinch point is that Norfolk Southern Bridge. It's what's causing the most backup. Now, all of the bridges have some hydraulic inefficiency by their nature, but to the level that they're not close to the level that the Norfolk Southern Bridge is. There's a question about gates and a question about emergency spillways. There are no, we've designed these structures without gates at present. They are designed to have a primary spillway that functions much like a culvert does, so it's always wide open. We do not have gates associated with any of these dams. Where are the emergency spillways? So there's 2 emergency spillways. Well, there's 1 emergency spillway on each dam, and the emergency spillway on these are shown to be roughly here, and on Potato is over here, and on Eagle Creek, it runs from there to there. So the emergency spillways are there to, in case of emergency. They're there to carry water if an event larger than a 100-year flood were to occur, if the culverts were to get clogged or anything like that. And they're designed such that they allow the dam to overtop, and what we have them designed right now to be concrete structures. They allow the water to safely pass over the dam and then down the river. This gets in, there is a question about, I was also going to talk about your question about the type of dam. Because of the storage volume of the dams that are here, they're classified by the state of Ohio as high hazard dams. What that means is they have to be designed to a certain standard. The emergency spillway has to design to carry a certain flood. In this case, the high hazard dam, hazard class 1, has to carry the full probable maximum flood. The probable maximum flood is the largest flood that's meteorologically and statistically possible. So to give you a case in point, Eagle Creek, the 100-year on Eagle Creek is 3,000 CFS. The 100-year on Eagle Creek is 4,000 CFS. The 500 on Eagle Creek is 5,000 CFS. The PMF on Eagle Creek is like 23,000 CFS, I think. So it's 4 or 5 times the 100-year event to get there. And this emergency spillway is designed to carry all that water. So the reason they're categorized that way by the state of Ohio is because of their size and their storage volume and their risk of life should the dam fail. So the emergency spillway is put in place so it does not fail. And the emergency spillway is designed to be so robust that it can carry 100% of the PMF. Question on Mount Blanchard, will 187 be closed? There is a portion of 187 that will be closed during the 100-year event. Just did that one. So the question about the soil for the dams, where will it come from? The soil for the dams will come from the immediate vicinity of the dams themselves. So in this case, we're not proposing to dig a big hole anywhere. We're going to kind of excavate as we go along the dam to build this embankment. The embankment height here is between 12 and 7 feet tall in places. At the highest point here, it's approximately 30 feet. So the soil that will be used for that will be excavated from the immediate vicinity around the embankment. So a question about the level of reconnaissance that Stantec's done. Have we done more than just aerial work? In places, yes. Where we have had access from public right-of-way or from the river itself, we've sent some letters to different property owners that we looked at specific areas. We have had some boots on the ground in some places along the Blanchard River. We've not looked at every inch of it, that's for sure. We have tried to be respectful of people's private property. But we have had boots on the ground in certain locations, specifically at the locations where we're proposing this infrastructure, where we've focused our kind of detailed field reconnaissance on the areas where the hydraulic improvements are happening, and at the proposed, along the western diversion of Eagle Creek at several locations, and also at the possible locations of the dry storage basins. So to talk about rainfall and where it falls, I'll talk about this a bit. So some questions about what happens if the rain were to fall north. The Blanchard River runs right here. So if this cell were to go right over here, right over the Blanchard River itself, it wouldn't have near the impact, because as you move away from that center of the storm cell, a lot of that rain is obviously outside the watershed, but as you move away from that center, it gets much, much less as you move south. So the important thing to note there is if the rainfall were to fall on the very, very northern part of the watershed, the timing is such that a lot of that water would flow out before that second part of the water from Eagle Creek, Light Creek, and Upper Blanchard were to get there. What we're looking at as far as how the rainfall were to fall, we're looking at multiple different scenarios, but kind of the worst case is if it kind of tracks this way, kind of right through the center. That's kind of what we're looking at as kind of the general storm. Now we'll look at multiple options where it tracks closer to 2007 then, even higher, and even lower, but we'll look at all those. The reason it doesn't matter all that much here is primarily based on timing of when the rain falls and how it would flow out. Some talk about Swell Park, the area around where the old wastewater treatment plant was. There are a lot of questions about that. We did look at that area as well. We looked at taking the old levees that are there, the fill that was there, and removing those and making that area similar to the widening area that we're looking at to the north of the river. And we looked at different options there. Again, it's all about how much that would cost and how much benefit you get. You would get a slight benefit if you were to take that area out, where the ball fields are and where the old wastewater treatment plant was. But the reduction in the 100-year level is a lot less. Again, it's another tenth or so, as opposed to the foot that the hydraulic improvements get you. The question about funding, as I said earlier, the question about funding, how much people will be taxed if federal funds are not available, and where will the money come from? As I said, the funding strategy for the full program is not in place. Question about cost estimates and the benefit cost ratio. The benefit cost ratio and the economic evaluation report is available on the webpage if you want to get more information on that. Our new road cost figured in. Yes, we did factor in new road costs. For example, on Eagle Creek, I'll show here, we did factor in some new road costs. This red line shows a new road that would link this area over to 68. So we did include some of those road and bridge mitigation costs in the capital costs that we presented to you tonight. Some questions about, again, how are you certain on costs and that kind of thing. You haven't done detailed design and that kind of stuff. You haven't gone through negotiations with property owners, and all that's true. The cost estimate we prepared for you tonight are fairly conservative. All of the cost estimates that we've include a 30% contingency. As I mentioned, the Corps of Engineers had a 27.5% contingency. Our costs include 30% contingency. We've done our best to have, based on real world construction data, what it costs to move a cubic yard of earth, what it costs to build a bridge, what it costs to do those sorts of things. We do have data on those costs from a number of different sources. ODOT has a very detailed cost records. ODNR does, different entities do. So we feel confident in our costs, that they're conservative, and they do include a 30% cost contingency for unforeseen things that come up in design and permitting and construction. Will the Conservancy Board not hear questions? And I talked about how the judges are elected officials. And, what will the ground covering be along the Blanchard River through the benches and the hydraulic improvements? So the ground cover on the river bank will remain trees and woody material, willows and shrubs, and the bench will just be herbaceous vegetation, green space, grasses and shrubs and that kind of stuff. So it'll just be green space. Public comment on the hydraulic improvements. A question about when that will come to be. We do not have any additional public information sessions scheduled at this time. We'll probably work through some of the detailed design and get a bit more information on that before we schedule those. I would expect perhaps we'll have some, perhaps in the fall or the winter, once we get through some of our data collection, survey, and geotechnical work. None of those are scheduled as of yet. Pumping, a question here about pump stations. I found this very interesting because the first sentence says, in New Orleans, there have been some very large pumps installed in the river and in around Lake Pontchartrain. And the reason I find that interesting is that my team is actually designing those pump stations in New Orleans. It's called the Permanent Canal Closures of Pumps. The largest pump stations in the largest stormwater pump stations in the world. Question about could something like pump stations or something like that be used on the Blanchard River? Could it be used to reduce damage or perhaps perhaps something to incorporate pumps? We did look at perhaps using a similar idea to the pump stations in New Orleans. We looked at the reservoir to the east of town. We looked at taking that reservoir and installing pump stations, 2 pump stations, one in the reservoir to dewater the reservoir, and one in the Blanchard River to pump water out of Blanchard into the reservoir. Kind of time it up. When you know a storm is coming, big pump station, dewaters or empties the drinking water reservoir. When a flood comes, pump water back into the reservoir to hold it, and you've got it maintained. In theory, yes, it works. The volume of that basin is not that great, and also the pumping stations would be an exorbitant cost. They would cost a lot of money to build those types of pumping stations. The pumping stations in New Orleans, the 3 that are being built right now, are about $700 million. The community, and you say it's about the community, Eagle Creek, Mount Blanchard, and some questions about the costs and benefits to those different communities. Why not talk about those? We haven't done that yet. We haven't done a benefit cost ratio specific to Eagle Creek Township or specific to, the only Finley, or specific to any of those communities. What we have done is a regional benefit cost ratio work around Hancock County. Flood walls, would flood walls work? Flood walls, we looked at flood walls. We looked at different things. In addition to cleaning the Blanchard, we looked at flood walls on the Blanchard River, along Eagle Creek itself. We also looked at developing a high velocity channel through Eagle Creek or Blanchard River. What I mean by high velocity channel, I mean taking the thing completely down to bare earth, taking all the trees out and putting a giant high speed concrete canal to carry the water very, very fast and out of town. Again, those kinds of things, the flood walls would have to be very, very high, and they're much more expensive because you have many more impacts and business buyouts, road buyouts, all that kind of stuff. Those have to be very high and are very, very expensive, and they have to be very, very coordinated with all the roads and bridge crossings. Flood walls, while good in theory, aren't really a viable option here in this situation. The high velocity channel, we looked at that, and even if you take the thing completely down to concrete, take all the trees out and make it a rapid, high velocity channel, get the water out through town very, very quickly, it still does not have that reduction. It still only is about a foot and a half, maybe at best 2 foot reduction. It doesn't quite get you there to that 4.5 foot reduction that the new goal is. They're very, very costly to build. Again, they'd be very, very costly, hundreds of millions of dollars probably, as well as they're very, very costly to permit, more costly to permit than the concepts we have. Question about Eagle Creek, where the soil comes from and regrading. We're not proposing on Eagle Creek or the Mount Blanchard to dig a detention basin or dig a big pit or dig anything. We're just taking soil from the immediate vicinity to build the berm. Did you have? And then that's all I have. Steve has a couple questions, couple comments.